Okay, hi all. So in this video, I'm going to show you how to count significant figures for chemistry problems in less than 10 minutes. Hopefully, because I really don't want to edit more than 10 minutes of footage. So let's go straight into it. First of all, what are significant figures, right? So significant figures are digits in a number that contribute to its precision and accuracy. So not all digits in a number count as significant figures. There's a set of rules to see which one count and which one doesn't. So here are the rules, right? First of all non-zeros, that means 1, 2, 3, 4, 5, 6, 7, 8, 9, count as sigfigs. So anytime you see a non-zero, they count as sigfigs. Rule number 2 is regarding zeros. So not all zeros count as sigfigs. Some do and some don't. And to tell that, you need to learn about the 3 types of zeros. So the first types of zeros are called leading zeros. And leading zeros are zeros found in the front of the first non-zero digits in a number. So for example, if you have a number 0.05, then there are 3 zeros in front of the number 5. So those 3 zeros are considered leading zeros. So you say that 0.005 has 3 leading zeros. And the rule for leading zeros is that they are never counted as sigfigs. So going back into that problem, 0.005, the 3 leading zeros in front of the number 5 are not considered sigfigs. So in total, the number 0.005 only has 1 significant figures. Moving on, the second type of zeros are called middle zeros. Middle zeros are zeros found between non-zero digits. So for example, if I have this number 5,000,000,2005, there'll be 2 middle zeros between the first 5 and the number 2, and another 2 between the 2 and the last 5. So there are a total of 4 middle zeros in this number. And the rule for middle zeros is that middle zeros always count as sigfigs. So going back into that example of 5,000,000,2005, all 4 middle zeros count as sigfigs. So in total, this number will have a total of 7 sigfigs. That is counting the 3 non-zero digit, 5, 2, and 5, as well as the 4 middle zeros. The last type of zeros are called trailing zeros. Trailing zeros are zeros found after the last non-zero digit in the number. So for example, if you have 53,000, then the 3 zeros after the number 3 are considered trailing zeros. Another example would be 530.00. Again, there are 3 zeros after the number 3, and it doesn't matter if there's a decimal point or not. As long as there are 3 zeros after the last non-zero digit, those 3 are considered trailing zeros, and it doesn't matter if it's found before or after the decimal point, all of them considered trailing zeros. Another example, let's say if you have 53.000, then the 3 zeros after the number 3 are considered trailing zeros. In this case, these 3 trailing zeros just happen to be after the decimal point. But it doesn't matter if it's after or before the decimal point. As long as it's after the last non-zero digits, they're considered trailing zeros. And the rule for trailing zeros is that trailing zeros only count as sigfigs when there is a decimal point present in that number. So going back to the example, if you have 53,000, then the 3 trailing zeros in this number are not considered sigfigs because there's no decimal point present in this number. So in total, you'll say that 53,000 only has 2 significant figures, that is the 5 and 3, because the 3 trailing zeros doesn't count. In the next example, let's say if you have 530.00, then the 3 trailing zeros in this case count as sigfigs because there is a decimal point in this number, right? There's a decimal point in 530.00, so that's why the 3 trailing zeros count as sigfigs. So it doesn't matter if the zeros are before or after the decimal point, as long as there's a decimal point in the number, all trailing zeros are considered sigfix. So in total, this number would have 5 significant figures. That is counting the 5 and 3 as well as the 3 trailing zeros. So let's go straight into a practice problem. How many sigfix does 0.005072000 have? So for long numbers like this, ask yourself a couple questions. First of all, how many non-zeros are there in this number? Here we see that there's a 5, a 7, and a 2. So far, there will be 3 sigfix, right? Because all non-zero digits count as sigfix. Secondly, ask yourself, are there zeros? And if they are, what type are they? And do they count as sigfix? So we see here that there are all 3 types of zero in this number. First of all, we see that there are 3 leading zeros in front of the number 5. There's a middle 0 between the 5 and the 7, as well as 2 trailing zeros after the number 2. So let's consider if they are sigfix or not. So first of all, the 3 leading zeros, they are not considered sigfix because the rule for leading zeros is that they are never considered sigfix. Next, we have the middle zeros between the 5 and the 7. These always count as sigfix, so that 0 count as 1 significant figures. Next up, we have the 2 trailing zeros after the number 2. These are considered sigfix because there is a decimal point in this number. So the last step, please count all digits in the number that are considered sigfix. So here after counting, we'll see that there's a total of 6 significant figures for this number. Moving on to problem 2, please count how many sigfix does each of the following have. And here we have 4 numbers. We have 53,000, 53,000 with a decimal point, and 53,000.00, and 0.5300. So let's look at each of them. First of all, I have 53,000. In this number, there are 2 non-zeros, which is the 5 and 3 in the front, as well as 3 trailing zeros. So first of all, the 2 non-zeros are always considered sigfix, so we have 2 sigfix so far. And for the 3 trailing zeros, in this number, there is no decimal point, so because of that, these 3 trailing zeros are not considered sigfix. And so in total, you'll say that 53,000 has only 2 sigfix. So moving on to part B, here we are counting sigfix for 53,000 with a decimal point. So again, there are 2 non-zeros, which is the 5 and 3, and 3 trailing zeros. So for the 2 non-zeros, 5 and 3, these are always count as sigfix. So far we have 2 sigfix already. And for the 3 trailing zeros, in this case, there is a decimal point in this number, so these 3 trailing zeros will be counted as sigfix. So in total, you will say 53,000 point has 5 sigfix. Moving on to part C, we're counting the number of sigfix for 53,000.00. Here we see that there are 2 non-zeros, which is the 5 and 3, as well as 5 trailing zeros after the number 3. So again, the 2 non-zeros always count as sigfix, so we have 2 sigfix so far. And for the 5 trailing zeros, because there is a decimal point right here, so all of these 5 zeros count as sigfix. So again, it doesn't matter if the 5 trailing zeros appear before or after the decimal point. As long as there's a decimal point, all trailing zeros are considered sigfix. So in total, you will say that 53,000.00 has 7 significant figures. Okay, the last question, part D. Please count the number of sigfix for 0.5300. So here you see that there is 1 leading zeros before the number 5. There are 2 non-zeros, which is the 5 and 3, and 2 trailing zeros after the number 3. So first of all, the leading zeros, the rule for leading zeros is that they are never count as sigfix, so that leading zero is not a sigfix. Next, we have the 2 non-zero, 5 and 3. Again, these are always considered sigfix. And how about the 2 trailing zeros? So these 2 trailing zeros are considered sigfix because there's a decimal point present in this number. And because of that, they are counted as sigfigs. So in total, just count all the digits that are considered sigfigs. You'll say that 0.5300 has a total of 4 sigfigs. And that's it for this video. I really hope that this has been helpful for you. Good luck on whatever quiz or exam you have upcoming. And if you still have any questions or if you need help with your specific problems, please fill out the Google form for a tutoring lesson with me. Thank you.